All right, BNS 380, are we ready to get back to male sexual behavior? I know I am. So last time we were in class, we had finished talking about um, the appetitive phase of sexual behavior in males. And so remember that the appetitive phase is everything leading up to the actual act of sex. And so we talked about dopamine. That was the last thing that we talked about. I'm going to be posting up these PowerPoints whenever I get through them. So this is going to just be a brief video about the consummatory phase. So as you can imagine, the consummatory phase of male sexual behavior includes mounting, intromission, and then of course ejaculation. I'm on my porch. So we'll see how this goes talking about this. So I'm going to lower my voice a little bit, right? Okay, so I don't think I need to explain what these behaviors are, but here they are. You can see in this picture, you have this little rat here, this one, pressing a bar for to have access to this female here. Okay, so one thing that's fun about rats is to think about that they have very specific behaviors that they do. We're going to talk a lot about rats because, again, most of this research has been done in rats. So it's very different. It's the biggest way that we understand sexual behavior. I will talk a little bit about primates in the next video. So rats have ultrasonic vocalizations. There are specific microphones that you have to record these ultrasonic vocalizations. But it turns out that when male rats are finished with their sexual act, they will sing. And they have been able to show this. And rats will also laugh if they're tickled. That's really funny because of their ultrasonic vocalizations. And again, we can't hear these normally, but it does appear that when males are finished mating, that they will sing afterwards, which I think is interesting. So generally what happens is after several intromissions and ejaculations that the male will clean himself and then generally ignores the female. So there's something called the post-ejaculatory interval. This is the PEI, and this is generally the time between when they ejaculate and they copulate again. It seems that males need to do this multiple times in order to successfully impregnate the female. Oh no, the male people just showed up. Anyway, so usually this time is between 5 and 15 minutes. The actual behavior of the male does vary from rat to rat, but generally this is the time limit. And so they will do this repeatedly for 90 minutes. And at 90 minutes, that's whenever they reach exhaustion. That's the exhaustion phase in which they will no longer mate with the female after 90 minutes. Now remember from 295, do you guys remember you guys remember the Coolidge effect? The Coolidge effect, to remind you guys, was when a sexually exhausted male will all of a sudden be perfectly fine when presented with a new female. So if after 90 minutes, this is whenever the rat will no longer be interested in the female that was there. But if you do put a new female in, all of a sudden he will be revived and ready to go. So that's the Coolidge effect at play here. But if he just has the same old mate, then he will continue to do this for 90 minutes. Okay, so now for the fun stuff. So one thing that's really interesting, I think, about erections is that the ability to have one is found completely within the spinal cord. So if you take a rat or male really, and you cut their head off, they are still able to do this. And they will be able to have, I'm very aware that I'm outside, out in the public, I'm sorry. They are able to have an erection to ejaculation, even without the brain. So this is something that is found within the spinal cord. Now the brain does help, and we're going to talk about some of those things in the brain as well. But it does seem like most of the nuclei in the brain are trying to prevent this from happening. So mostly what the brain is doing is saying, no, 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 no. Okay, now you can. And that's generally what happens. So one thing about hormones here, and are hormones involved? You might say, well, probably not if you don't need the brain. Well, hormones are one thing to remember about hormones is they don't necessarily cause anything, but they do change the likelihood that things will happen. So it does seem that when you have a male that is castrated, over time, their motivation to perform sexually decreases, and this is true for humans as well as rats, but also their ability to have an erection, maintain that erection, to ejaculate does diminish over time. So castrated males over time are unable to ejaculate. So it does seem that hormones are important. It seems that when it comes to erections, hang on, and hang on, what, Joe? Sorry about that. You know, I have Josie with me today. So again, what I was saying about hormones is that they do seem to change the likelihood that these things will happen. So now we're talking about the periphery, okay, because this is something, erections and ejaculations are found primarily in the spinal cord. So now when we think about testosterone and dihydrotestosterone, these are the two androgens that seem to be important for these things to happen. The higher testosterone one has circulating, and dihydrotestosterone, the more likely that one is able to have erections and perform to completion. So in this case, you actually do not need, because dihydrotestosterone is just as effective as testosterone, we actually do not need the aromatization into estrogen. Estrogen is important for your central nervous system. And so that's everything that's happening here. But now we're talking about peripheral. This is found primarily within the spinal cord. So you do not need, so aromatizable androgens are actually not as effective. So testosterone and dihydrotestosterone are important for this, but estrogen actually does nothing since it's acting in the central nervous system and does nothing in the periphery. So one thing is important is that, and this is especially when it comes to humans, this is where the environment and what you've learned over time becomes really important, because it does seem that that even though, if you say you've got your head chopped off, even though this is not here, you do need a certain amount of androgens circulating, and you do need a certain amount of stimulation. So stimulation does tend to be required in order for this to occur. And the brain comes in where we have made certain associations with things in our life that we associate with these things that can cause these things to happen. Okay, so let's talk about the actual process of ejaculation. And there is a nucleus in the brain that is beneficial for this. And it is the subparafascicular nucleus, or the SPF nucleus. And this is found posterior in the thalamus. So it is receiving information from the body. So this is coming in from the periphery, and it is being received into this particular nucleus in the thalamus. So this nucleus is activated during ejaculation. And one thing that I do want to point out about this particular nucleus is that it does have some pretty significant dopaminergic output. So there is lots of dopamine going on here, and that probably makes sense to you, right? And when you take this particular nucleus out, then the male is unable to ejaculate. So this is a critical nucleus for this behavior. But everything else seems to be just fine here. So this is an important nucleus in the brain for this behavior. It does have some other interesting things that it does. It does project to the inferior colliculus. You guys remember finding that structure in 295 with your sheep brain. The inferior colliculus, if you'll remember, is important for auditory associations. And so there does seem to be, this nucleus does play a role in audition to the superior colliculus, and these are dopaminergic inputs. There does seem to be a role for female sexual behavior. If you're wondering about that, is this purely for ejaculation for males? it does seem to play a role in what they have found in rats is that it is activated with vaginal stimulation as well. So there does seem to play a role for female sexual behavior as well, but that role is a little less clear. Okay, and then the final thing I want to talk about before ending this video is the preoptic area. We're mostly talking about the medial preoptic area. Remember that this is a nucleus in the hypothalamus. And so this nucleus is also important in the brain for consummatory sexual behaviors. It seems to play a role for integrating the peripheral sensations for everything that we've learned out in our environment that is stimulatory. It seems to bring all these things together and integrate it into what we know as our sexual experience. We talked about this already when we talked about dopamine and how the dopamine circuits are important. So it seems that missing this nucleus, the reason why it eliminates consummatory behaviors is because it is cutting off that dopaminergic input and output region from the preoptic area. So it doesn't seem to be the preoptic area itself, it's those dopaminergic inputs that are critical here. When you take out the preoptic area, the animal will really want to, like they're still motivated, they're gonna run on a treadmill, they're gonna press a lever to try and gain access to a female. But once that access has been achieved, they don't do anything. So it is specific seemingly for consummatory behaviors. The other thing so that's important whenever we were talking about dopamine. And then remember what I was saying about testosterone and estrogen, that these hormones are important for increasing the likelihood that these things will happen. All right, well, I will stop this here and I will continue on with our next topic. Thank you.